Alright, so in this video here we're going to talk about some of the important graphs of functions that you really should know about, that you should be able to identify, that you should be able to close your eyes and picture in your head what the graph looks like for some important functions where if you plan on taking higher level math courses like precalculus, calculus, and beyond that, you really should be able to identify these graphs and you should know what they look like without having to look them up. Like you should know when I say y equals x squared that the graph looks like this or like that is a better way to show it, right? So some of the more important graphs that you really should know. First one, a linear function, y equals x is just that, that straight line that goes through the origin. And if you change the slope or if you change the y-intercept, it moves the graph up and down. But this is the basic graph of a linear function. The same for all these other ones. You can do transformations to the graphs is what we call it. And I'll do a video or two later on where I talk about how to graph functions using transformations of these graphs here. So any of these can be moved up or down or left or right or spread out or stretched in one direction or the other. But these are just what the basic graphs of the basic types of functions look like, right? So for the linear function y equals x, it's that straight diagonal line that goes through the origin. For the quadratic function y equals x squared, right? So that's our basic quadratic function. A quadratic function, the graph is a parabola, and the vertex of that graph is on the origin, which means that that low point that the graph hits down here is right there at the origin. Right? So that's the basic graph of a quadratic function, y equals x squared. For a cubic function, y equals x cubed or y equals x to the third power, we see the graph is always increasing. It comes up on this side. It doesn't go straight through the origin. It kind of curves a little bit as it goes through the origin. It flattens out for a second, and then it continues to increase from there. All right, so that's the graph of the basic cubic function, y equals x to the third. We have the square root function, y equals the square root of x, right, which notice the square root function starts at the origin, right? It doesn't exist for negative x values because you cannot take the square root of a negative number, right? So the square root function starts at the origin and then increases from there, right? Kind of increases slowly, as you go along. It never really flattens out. It continues to increase. It just does it very slowly. And actually, the relationship between these two graphs, the x squared and the square root of x, in some of the other videos that I've done, I've talked about inverse functions and how they're opposites of each other and how one undoes the other one. Well, the quadratic function x squared and the square root function are inverses of each other, right? Raising something to the second power and taking the square root of it are like two opposite operations, right? So the relationship of the graphs of those inverse functions is if you take the parabola up here for x squared and kind of tip it over on its side and then just take the top half of it, that's the graph of the square root function. It's exactly the graph of the square root function, right? So if you were to label some of the points on here and then tip it over like that, this is exactly what you get. All right, so that is that one. And then the cube root function, y equals the cube root of x or the third root of x, the graph looks like this. And again, look at the relationship between the cubic function and the cube root function. Those also are inverses. They're opposites of each other, just like the square root and the x squared are, right? And notice this one, you kind of tip it over on the side and then flip it over this way, and you've got the graph of the cube root function. Just like you flip this one over and do that, and you get the same thing for the square root function. All right, so again, you should know when I say, oh, let's graph a square root function, you should be able to picture in your mind that the square root graph looks like this. Or when we say, let's talk about a cubic function, you should know that a cubic function looks like this, or a quadratic function looks like that, right? Basic shapes of the graphs you should be aware of as you move forward into higher and higher levels of mathematics. All right, now, there are a couple more that I'm going to erase these and put up a couple more because I just didn't have enough room on this little board here to put all of them. So I'm going to pause this real quick, erase these 5, and put up, I think, 3 more that you also need to know. All right, so I erased those ones that were up here. We have 3 more functions that you really should know what the graphs look like. The first one up here now is the reciprocal function, which is y equals 1 over x, right? Remember, reciprocal means flipping something over, like flipping over the fraction. So the reciprocal function y equals 1 over x looks like this, where you have this curve down in the third quadrant, and then like a reflection of that curve up here in the first quadrant, right? So that's the graph of y equals 1 over x. We have the reciprocal squared function, y equals 1 over x squared, which this part in the first quadrant looks similar to that. It's not exactly the same graph, but it has a similar shape to it. And then the one that was down here in the third quadrant kind of gets flipped up into the second quadrant. Again, it's not exactly the same, but it has a similar type of shape. And I like to call this one the volcano function because the graph to me looks kind of like a volcano going up there. But that's the graph of the reciprocal squared function, y equals 1 over x squared. And then the last one we have here is the absolute value function, y equals the absolute value of x, which is basically just a V shape, right? Where the vertex of that V is at the origin. And actually, this side, the one that's in the first quadrant, that's just the graph of y equals x, right? Because remember, for the definition of absolute value, when x is greater than 0, it just equals the same number, right? Like the absolute value of 5 is 5, the absolute value of 7 is 7, right? So this line over here is just y equals x. The line on this side is y equals negative x, right? So this one has a slope of positive 1. The line on this side in the second quadrant has a slope of negative 1. Those two line segments together that meet at the origin, that gives you the graph of that absolute value function. All right, so I think there were 5 on the first time I had the board up here, and then 3 more. So 8 functions that really you should know what these graphs look like. You should be familiar with the shapes of these graphs. They are important things to know and to be able to visualize. Or even when like you're doing a problem, you see something that looks like this. You're like, oh, that looks like the graph of y equals 1 over x. Right? They do come up fairly often in precalculus and calculus classes. So if you don't know them yet, start studying them, start trying to remember what these graphs look like. You'll need them again at some point.